Welcome to sysadmin. In today's explainer, we are going to explore architectures and protocols of the OSI reference model. Now, I know the OSI model can feel like this purely theoretical concept, right? Like something you just memorize to pass an exam and then completely forget. But honestly, understanding this structure is absolutely vital for real-world enterprise networking, cybersecurity, and especially troubleshooting. When a server goes down or a user suddenly can't reach an application, knowing exactly how data travels layer by layer, that's what separates just randomly guessing from professional, precise problem solving. So let's break this down together.
Here is our roadmap for today. We're going to start with an introduction to OSI architectures, then move down through the top layers encapsulation. After that, we'll navigate the network and data link layers, finally hit the physical hardware components, and wrap it all up with a quick summary of network principles. Let's jump right in.
Section 1. Introduction to OSI architectures. We're going to look at how data travels logically from a user's screen all the way down to the physical cables.
You can really think of network communication as a giant assembly line. When you decide to send data over a network, it doesn't just magically fly through a wire exactly as it is. No way. The network layers act like this highly systematic conveyor belt, constantly adding instructions, which we call headers, to the data as it prepares for transport. It's exactly like a shipping process. An item goes into a box, a shipping label gets attached, it goes into a larger crate with its own routing info, and then it's finally loaded onto a delivery truck.
Section 2, the top layers encapsulation. We're starting at the very top of our assembly line here, where a user is actively working on an application and actually makes the decision to save or send data across the network.
So here's how the encapsulation process works step by step at these top layers. Think of it kind of like nesting dolls. First, the application layer wraps the user data in an application header, or AH. This specifically tells the receiving end which user application sent the data. Then it hands it down to the presentation layer, which adds its own wrapper, the presentation header, or PH. Finally, the message drops down to the session layer. When the session layer gets it, it initiates synchronized communication with its partner on the receiving end and wraps the data once more in a session header, or SH. The whole process is brilliantly repetitive. Layer by layer, it receives data, attaches a specific wrapper, and passes it down the line.
Section 3. The network layer. Now, a quick note here. Between the session and network layers, the data briefly passes through layer 4, the transport layer, where it receives a transport header to create what we call a segment. Once it has that, it arrives right here at the network layer. When the network layer receives this segment from the transport layer, it has one absolutely crucial job. It adds the destination network address information to the communication header. This is essentially the routing intelligence of our entire assembly line. Without this specific destination address, the data literally wouldn't know which network it was trying to reach. After this critical location info is attached, the network layer sends the entire package down to the data link layer. We've talked a lot so far about software, protocols, and digital headers, but you might be wondering, how does this data actually physically travel across the network? How do we get from abstract software instructions down into the hard realm of physical hardware?
That brings us to Section 4, the data link layer. This layer is the critical bridge that offers the physical addresses needed for devices to actually talk to each other while also ensuring data integrity along the way.
To really understand how it does this, we need to clearly isolate and define its two distinct sublayers. I know, acronyms can feel super overwhelming for beginners, so let's break them down simply. The data link layer consists of the logical link control sublayer, known as LLC, and the media access control sublayer, known as MAC.
Let's compare the two. The LLC sublayer acts almost like a shield. It protects data by providing services to higher layers and performing error checking and flow control. The MAC sublayer sits just below that and acts more like a traffic light. It strictly provides addressing and channel access control to direct the flow of network traffic. So just remember, LLC handles the error and flow control shield, while MAC handles the addressing and access traffic light.
Now, in a real enterprise server room, this is exactly where you troubleshoot physical hardware. If you're configuring a network interface card or plugging into an Ethernet switch, you are working directly with those MAC addresses at the data link layer. Token ring switches and network bridges also operate right here. These are the physical devices that are actively routing data based on the specific MAC addressing we were just talking about.
Moving on to Section 5, Physical Layer and Components. We have finally hit the very bottom of our data assembly line. It's actually pretty fascinating to consider what the data looks like at this stage. All those software headers we discussed are finally transformed into the physical realm. This exchange happens via raw electrical signals over copper wire, audio tones from a speaker, or even rapid pulses of light shooting through glowing fiber optic cables.
The physical layer also defines data terminal equipment, or DTE. Think of the modems or CSU/DSU units that bridge your enterprise router to the outside world. These are entirely responsible for the timing, clocking, and switching of those raw data signals. They take the packets and handle the exact, precise timing required to push them smoothly across the wire.
As a sysadmin, this is your physical domain. We're talking about the messy cabling systems, the wireless antennas, parallel SCSI interfaces, and basic hardware like hubs and repeaters. When a patch panel goes bad or a network interface card fails right at the connection level, this is the exact layer you are fixing. It's the tangible, hands-on bottom of the whole network stack.
Section 6. Summary of Network Principles. Let's do a really quick review of the architecture we've just mapped out together.
To recap our top-down flow, first, top-down encapsulation wraps the data in application, presentation, session, and transport headers. Second, the network layer jumps in and attaches the crucial destination address. Third, the data link layer splits the workload into the LLC shield for error control and the MAC traffic light for addressing. And finally, the physical layer pushes the whole shebang through tangible cables, hubs, and wireless signals.
So I'll leave you with this final thought to ponder. Which layer of the OSI model will you investigate first the next time your network goes down? Will you start by checking the physical cables, or will you look at the network layer routing? If you found this helpful, subscribe to Sysadmin Academy and continue building your IT expertise.